Hello and welcome to the Slippery Slope Show. I'm your host, Gary Hoffman, with co-host John Lee. Say hello, John.
Hi, everyone.
Just like the song said, we're going to take you on a magic carpet ride to the intellectual peaks of your neocortex and down into the valley of your basal ganglia and back again. So today's topic is robots, automation, and unemployment. And so before we get into the actual discussion, I'm going to just do kind of a quick overview of robots and automation. A lot of you are probably already familiar with robots. It's very popular in pop culture. You've probably seen a bunch of movies where robots are some of the main characters. One of the most popular is, of course, Star Wars, where you have C-3PO and R2-D2. They're kind of the friendly robots.
Jungle Boogie, Jungle Boogie, get it on. Jungle Boogie.
Then you have the Cyborg, which is Darth Vader, where technology is keeping him alive, although he's never referenced as kind of a cyborg. You also have films like Terminator, kind of a dystopian view.
Sakono.
Sarah Connor?
Yes.
It's robots run amok, and then they
Try to kill the human race.
Exactly. So that's a bad thing. And if you go way back, even in sort of the earliest films, there's a film called Metropolis, which is one of the few films that has a female robot.
An iconic female robot.
Right, and she's. It's interesting because there hasn't been like a bunch of, you'd think that because that was one of the first ones, that there'd be a bunch of other films where they have like evil female villains who are robots. I guess they did that in Terminator, in one of the later Terminators.
Terminator 3, Rise of the Machines. Right. A terrible movie, but
yeah, don't go see
for
that
another
movie.
time.
Yeah. So if you want to see one of the early, we'll put a link for the Metropolis video. You can watch it on YouTube.
alive. Oh, it's alive. It's alive. It's alive. It's alive. Oh, in the name of God. Now I know what it feels like to be God.
So it's been covered, you know, in a lot of films. Of course, we see robots in factories and everything else. But if you, and I'm going to try to keep this kind of short in scope, because if we go way back, if we want to talk about robots, you can go back. The ideas of robots go way back, to maybe 100, if not 1,000 years. Like Da Vinci. Da Vinci actually had some robotic ideas as well.
Well, if you want to go even older than that, there's the idea of the golem, right? Which is like this, animated rock being that like becomes its the servant. It's like in Jewish mythology, I believe. It's the idea that like this guy animated this golem to do his biddings and stuff like that, which is basically their concept of a robot, right? Like it was like a golem that just follows orders and does what the master tells it to do and things like that. So if you really want to go back thousands of years.
So are they making reference to that in the Lord of the Rings with the Gollum character?
Well, I do think, obviously we're getting off topic again, but I think there's probably part of the reason why Tolkien chose that name for that character. I just reference back to the Gollum of the mythology. He probably had something to do with that, yes.
Okay, so for purposes of review, I'm just going to keep it sort of to American history, going back to the 1800s, where we saw sort of a really big transition where there used to be horses in every city in America. You'd go there, you'd see horse-drawn carriages and horse-drawn carts, and then you saw these horseless carriages, which we call cars. We take it. A lot of people don't think about your car. That's just short for carriage. And initially, those cars were not only the rich people owned them. They weren't super efficient. They were just a kind of a showpiece.
Status symbol.
To impress your friends. But they gradually became better and better. And then, of course, Ford came along, who automated the assembly line, and that's been great for America, right? And so, but it wasn't so great for horses, right? So what happened? You don't see horses now. What do we use horses for? We use horses for entertainment. We use horses for, you go ride a horse, you go horseback riding, or you go watch the Kentucky Derby.
Hello, I'm Mr. Ed. A horse is a horse, of course, and no one can talk to a horse, of course. That is, of course, unless the horse is the famous Mr. Ed. Go right to the source and ask the horse. He'll give you the answer that you endorse. He's always on a steady course. Talk to Mr. Ed.
So it displaced horses. You
Yeah.
also saw the horses displaced in the field. People don't think about that. It's like, unless you're Amish, nobody uses horses to plow the fields anymore.
I would bet if you did a study, the horse population, let's say in the United States, drops drastically over the last 100 years.
Hi, I'm Suzanne Kinzenbaugh-Veach, Vice President and Chief Marketing Officer at Kinsey, and we are very excited about a brand new project we have just released called the Kinsey Autonomy Project. And basically, Kinsey was founded upon innovation and maximizing grower productivity, and that's what this project is all about. We have a solution for planting and a solution for harvesting, and by autonomy, what we basically mean is the tractor and planter or the tractor and grain cart are literally going through the field without a person in the cab. And again, this is to maximize the grower's productivity, so he doesn't have to have an extra hired hand. He can run longer hours, potentially, if he chooses to do so. The way the harvesting application works is the combine operator will call the tractor and cart when ready to unload. It'll come up alongside and follow while the combine empties out. When the cart is completely loaded, it will go over to a safety zone, which is a coned out area that the tractor recognizes through GPS mapping, and it waits for the semi-operator to come, and then the semi-operator manually unloads into the grain cart. This project is not intended for on-road use, only for in the field. So again, if the tractor gets moved down the road, that gets done by an individual. And the tractor has sensors on it, so it senses obstacles, it senses a person or an animal that might come into contact around it. So again, very safe in the field, and those are proven commercial grade sensors that are used in military applications and whatnot. As far as the planting application, basically the grower goes, maps out his entire field, and then the tractor literally knows where to go and drop the planter, take it through the field, lift it up, turn around and make the next pass back. So again, really neat how it works, and we have both of those videos on Kinsey.com and on the Kinsey YouTube side if you want to see both of those working.
Right. Now, it hasn't all been bad, because imagine how many people would be starving to death if we were still using horses to plow the fields. Right? That's an incredibly inefficient way. So the tractor has allowed us to, of course, plow a lot more field, right? And we have a lot more food, and as a result, we can have much larger population. So,
and obesity.
Right, and exactly.
Oh, you're gonna take me home tonight. Oh, down beside that red firelight. Oh, you're gonna let it all hang out. Fat bottom girls, you make the rockin' world go round.
A lot of people talk about automation and as it's automatically a bad thing. It's going to displace. Yeah, it displaced horses. It displaced the guys who made carriages and saddles. They all lost jobs, right? The guys who were making the plows for, but the guys who are making plows for, say, horses now made plows for tractors. They did even better, right? So, and of course, all of us, we have all this cheap food, and so it's not necessarily, we're not here to talk today like we hate technology or we hate automation, but we do want to talk about how is technology going to affect us as individuals and also the unemployment rate. And so, kind of getting us more to the present. Recently, Apple announced that they were going to invest billions of dollars in partnership with one of their major assemblers is Foxconn. They're based in China, and you guys have probably heard about all the articles and news about how Foxconn treats. There's been all those suicides and whatnot. So they are investing billions of dollars in robots to automate the process, which will probably result in cheaper iPhones, but it's going to displace a lot of those people who were previously putting pieces together by hand. And so a lot of people who are listening might be unemployed. And we have a high unemployment rate. It's 8-point-something% today, but that actual percentage is not the true percentage because the government has decided to define unemployment based upon their own standards. So if you're unemployed for too long, they stop counting you. And so the actual unemployment is probably double that or higher. So there's a lot of people who are unemployed who might be wondering, like, how is this fast advancing technology going to affect their employment prospects? Also, there was a recent article that we read in Technology Review. This isn't new material, but a lot of economists have noticed that the productivity has gone up in all these companies, but the unemployment rate is staying high. And this is one of the first recoveries that we've had where the GDP has recovered. So the corporations have recovered, but there haven't been a bunch of people getting hired. And a large reason for that probably is because they're doing more with fewer people. And so the question we have is, what happens to all those people who lose those manufacturing jobs? Are they displaced permanently? And what are they supposed to do? So if you had a manufacturing job or you were in a job that required just manual labor, what are your prospects for becoming obsolete? And that's one of the questions that we have in this show. Is technology going to permanently displace millions of Americans? And I'm going to throw this over to John to talk about. John, do you think that all of this technology, that these people who are in their 40s or 50s who've lost their jobs because of automation, that they're going to be potentially permanently displaced from the workforce?
Well, I think I think there always will be a percentage of those people that will be, because there will be people who will train for new skills and things like that, but then there will be people who won't. But I'm not convinced, though, that the reason why for the lack of employment is strictly because of this automation. I mean, I do think automation has had an impact, but I'm not convinced that's the only reason. I do think because of a lot of these corporations you're talking about, I don't think automation is the reason why this has happened. I mean, there are companies, sure, like Amazon and places like that, but you're not going to tell me, every single corporate, even some large law firms or large, these type of firms, they're increasing productivity, or like Goldman Sachs or whatever, that their increase in productivity is because of automation, because I just don't buy that.
That may be true, but what about companies that, let's say, like, and this is kind of a related issue. If you're a business owner, let's say you own a McDonald's or a fast food restaurant or just any restaurant at all, and you have the cost of labor. The cost of labor is, of course, the minimum wage law, right? On top of that, whatever health care benefits that you have to pay for people. And right now it's the big manufacturers that are bringing in these robots, because if you're building a car, you can run 3 shifts, right? And that thing can do repeated processes over and over. Whereas a restaurant, you only see so many customers in a day. You're not at the same volume of, say, a General Motors or a
and you
Ford.
can't really increase your volume, right? Because your volume is your volume.
Right. But as the cost of these robots come down, right? Because we haven't reached an inflection point where you can just get cheap robots that can, say, make a hamburger. But if the cost of a robot to make a hamburger is on a $1 to $2 per hour, and you're paying $12 to $14 an hour for employees who sometimes call in sick, who sometimes don't do their job very well, who, depending on their moods, because people have emotions, computers don't. That, wouldn't it make economic sense for you to actually just, if you could get a robot cheap enough where it was $2 an hour, to actually replace the worker with a robot?
Well, then you're talking about the future, right? I thought your question was about what has happened already. I mean, if you want to project into the future, yeah, I could definitely see a scenario where more and more of these automations will take away a lot of these more, less skilled labor jobs that people have.
Some people would say that, but isn't that an example of sort of the tyranny of robots, that these robots are going to replace the people? Because if you look at the corporations, it's great for the corporation if you can eliminate a bunch of your costs, because employment is a huge percentage of your cost structure, and replace them with robots that do not require pensions or do not require, because humans are very creative, right? So I think you're right. Like creative positions, we have to do a lot of creative thinking. That's going to be one of the high watermarks. And Hans Marovic talks about this in an article that I'm going to also provide as a link if you want more background. And he believes that ultimately all jobs are lost. So, but I'm not making that statement.
Are people becoming obsolete? A giant electronic brain has started cogitating at the University of Pennsylvania. It's made a vacuum tube, like your radio, and it can add up a column of figures a yard long in a second. It's the world's first electronic computer. Right now, it's solving mathematical problems for the U.S. Army, but who knows, someday a machine like this may check up on your income tax.
So imagine the human abilities as kind of a landscape with some peaks, which are the things we do well, and some valleys, which are the things we do really, really badly. There are things that we do extremely well, which are things that were important in our survival for most of our evolutionary history, things like moving around and socially interacting and perceiving the world. And there are things that we have only recently learned how to do, things like general reasoning. An extreme example is arithmetic, where we are very, very, very inefficient. Computers are different. They are universal machines. With an efficient program, they can do almost any one of these tasks equally well in some abstract informational sense. So the skill of computers can be likened to a water level that's uniform. The water level is rising. And it's rising at a rate that is about 10 million times faster than the rate at which we evolved those abilities. That and a number of other calculations lead me to believe that the highest peaks will be covered by this rising flood in less than 50 years. But once the level of computer competence has risen beyond the best human engineers, then there won't be any human engineers. There will be robotic or computer engineers.
For the corporations, their duty is to their shareholders, and the shareholders want to make as much money as they possibly can. So if you can replace the line worker, you can replace, you know, the cashier with, in which we're already seeing that. It's not like this isn't even projecting into the future on the cashiers. You can go to Walmart, you can go to Kroger's, you can go to lots of stores and you have automated checkout, right?
Yeah, and interestingly enough, often I prefer to go to the automated checkout, especially I don't have a lot of stuff. If I'm just like buying like 5 items, doing a quick grocery run, I'd much rather go through the automatic than having to go through the person cashier, because I think it's always faster the other way. So.
And so what do those people do who've been displaced? I mean, if they don't have a high level of skill, and you have a government that doesn't really have a program to really retrain these people with those skill sets, what are the odds that they're going to actually be employed in the future?
Well, the way I look at it is like I think the economy is a much more dynamic place. You know, I mean, you could say the same thing about 100 years ago. Where are all those wagon, you know, drivers, the horse wagon drivers, and the people who took care of horses, the horseshoe blacksmith, and the, you know, the stable boys, and where are those people going to find jobs, right? Yeah, I mean, but jobs eventually, I mean, as the economy becomes more efficient, there are more money, people, farms becomes more productive, all these things, people's income, disposable income goes up, they'll spend their money, they'll want to spend that money, and then the businesses will emerge to cater to those type of wants and needs, and then they're going to have to hire people for those businesses. So, I mean, I don't have a, you know, crystal ball that tells you where those people are going to find jobs, but I think people underestimate the dynamic nature of an economy to think that those people will just be permanently unemployed because there's no job will emerge for them.
But is there a difference between, you know, cars displacing, because at the end of the day, even when you went to a car, it needed a person to drive the car, right? It didn't displace, it displaced horses. You know, the horses have been dramatically affected, but it wasn't displacing humans. You know, what about like when, for example, like driverless cars? You know, eventually there'll be driverless trucks. That's going to displace all of the guys who are driving truck today. You know, it's going to displace taxi cab drivers.
So welcome to Artificial Intelligence for Robotics. You are entering an exciting 7 weeks class in which you learn how to program self-driving cars. And just to motivate what we're trying to achieve in this class, let me show you some videos. So my interest in self-driving cars started with the DARPA Grand Challenge in 2004, in which my team at Stanford developed Stanley, a robot that could drive itself through the Mojave Desert. The vehicle was based on a Volkswagen Touareg. It was equipped with all kinds of sensors like GPS and laser, and it was able to make its own decisions without any human input whatsoever. The DARPA Grand Challenge was a government-sponsored race that took place in 2005. Here we see our robot Stanley moving through the desert completely without a human on board. The task was to drive a desert trail for about 130 miles, and whoever was fastest would win the race. Here we're passing a different robot by Carnegie Mellon University about 110 miles into the race. Our robot was able to navigate really steep mountainous roads and able to avoid collisions with rocks or falling down a cliff, all based on its ability to use what I'm going to teach you in this class. After almost 7 hours and 131 miles, our robot returned all the way to the starting base as the first robot to ever finish a DARPA Grand Challenge, winning Stanford University $2 million and Stanley a place in the Smithsonian Museum of American History. This work led to the Urban Challenge, in which we built another robot called Junior that eventually took second place. The Urban Challenge was a follow-up race by DARPA in which cars were asked to drive in traffic. So whereas the Grand Challenge was kind of a motionless desert floor, this was a mock urban city where the robot was able to interact with other traffic and had to follow traffic rules, as in this left turn over here. Had to be able to stay on lanes with very high precision, accommodate oncoming traffic, and just drive confidently in a situation that really resembled a small city. This led at Google to a sequence of experiments known as the Google self-driving car, and I believe these are the best robotic cars out there today. Here we see one of our Priuses on University Avenue in Palo Alto, kind of undetected, driving just like a human driver, but this car is driving by itself. Our cars have been able to drive hundreds of thousands of miles all across California and some of Nevada, in downtown areas like San Francisco, on busy highways, here in Monterey, a small coastal city in California with lots and lots of pedestrians. And these are all completely self-driving moments where the car is able to accommodate things like deers in the headlight in the middle of the night, or even crooked Lombard Street in San Francisco, as shown in this video. This is what I'm doing on my day job. I really love, with my team, building self-driving cars. We believe it's going to really change the world. And in this class, that's what I hope to enable you to do. So let's dive in.
And so I agree that there'll be new opportunities created, but I guess my question is, if those new opportunities require high skill sets, I mean, what are the odds that the new opportunities are going to, because if it's just the new opportunities that are created, all the jobs that are just basic that a computer could do or a robot will do will just be using a computer or a robot to do it, right? Most of the new jobs are going to probably require a high level of skill, and if these people are not highly educated, how are they going to get jobs?
Well, I do think, I mean, this is like one of my personal theories on this, and is that as people get more and more productive, as you have people who, have to work less hours, especially highly skilled people who don't have to work the same hours to get the kind of income they have and things like that, there'll be just a lot of people. I think the big industry of the future is entertainment. I mean, that's gonna, because you have to spend time to keep those people occupied. Television, internet, computer games. I mean, like the biggest thing now, I think, is like the interactive entertainment, like the MMOs, things like that, those gaming and all kinds of like those type of things, mobile devices, and all those things are designed to, like, I think most of the new jobs are going to be in those type of industries. I'm not saying exclusively.
Let's just go along with that even further. But those jobs all require a high level of skill. So if you want to design a massively multiplayer online game, you have to be a computer programmer, and that takes a lot of discipline and investment. And not everybody has the skill level to be. But some people that are listening actually have the propensity to be able, or the aptitudes to become a computer programmer. But if let's say you're 55 years old or 50 years old, and you just lost your job as a truck driver or as working the line, they're not going to become a computer programmer. You're not saying that that's their only way out, are you?
No, I mean, like I said, if those labor exists in those labor supply exists in the economy, I know this is kind of like people say this is a blind faith or whatever it is. I believe in the dynamism of an economy to, when that supply exists, there'll be people who find a way to utilize that supply. Now, the problem, of course, you have is, and this is why, I always talk about the fact that regulations, government regulations, tend to actually restrict that dynamism, because the problem is, if you have a lot of employment laws, you have a lot of these type of things, or even minimum wage laws, whatever. I mean, we can get into that discussion some other time, but all these things restrict the dynamism, right? You can't, so that new businesses cannot emerge to take advantage of it, because all these laws, kind of tie their hands. If we have, I believe, like, if you really allow the industry, the economy, and the businesses and individuals in there to be more free, then more of these opportunities will happen.
Which brings us back to Google Plus for a moment. We are not actually on Facebook, but if you would like to follow the show or interact with us, just go to Google Plus, set up an account if you don't already have one, and just type in The Slippery Slope Show, and then you can follow our page. We also do a lot of Hangouts. And that's one of the main reasons that we're actually on Google Plus, is that it allows us to actually have conversations with people. So we'll do Hangouts where we talk with people and get show ideas. So if you want, you can follow us, and once you follow us, when we do a Google Hangout, it will inform you, and you can join us. We'll do some stuff on air as well, where you can actually make comments while listening to the show.
This is the end, beautiful friend. This is the end, my only friend. The end of our elaborate plans. The end of everything that stands. The end. No safety